Access Control System Design Basis. Design life. The access control systems are designed as operation for a minimum of 10 years without requiring upgrades due to technological obsolescence. Access Control System. The system provides access to authorized personnel with valid smart cards at various facilities, including pumping stations, block valve stations, control rooms, and administration buildings through a centralized access control system. Components include smart cards, card readers, door strikes, door switches, microprocessor-based controllers, database servers, workstations, and security management software. System spare capacity and spares. Hardware: 20% spare capacity on interface I/O cards, wired and terminated. 15% spare cards, terminations, and slots available but not installed. 25% expansion space in cabinets for future needs. Systems, servers, workstations: 30% maximum system memory utilization under full load, with space for 50% memory upgrade. 50% spare storage capacity memory with additional space for future upgrades. 100% spare software license capacity for future expansions. 50% spare historization storage space for servers. Other spares. Vendor recommendations apply. Power supply. Main control rooms. Single source of 240 AC 50 Hz, single-phase power from a UPS. Block valve stations. 24-volt DC power supply provided through solar power systems. Standardization of equipment. Standardized equipment across all sites to ensure commonality of spares, minimize training, economies of scale for purchasing and maintenance, and uniform system upgrades. System availability. Designed for 99% operational availability, excluding power, transmission issues, and scheduled maintenance. Access Control System Design. Designed for various locations along the stretch of the pipeline, including main control room, MCR, block valve stations, BVS, intermediate control room, ICR, and main terminal, MT. Access gates locations. Card readers and gate door controllers are installed at main gates, personnel and vehicular, control room buildings, substations and switch yards, administration buildings, restricted areas as required. Access control system locations. Main control room, master access control workstation in administration building, security workstation at the main gate. Intermediate control room, ICR, access control workstation in administration building, security workstation at the main gate. Main terminal, MT, alternate master access control workstation in administration building, security workstation at the main gate. Block valve stations, BVS, unmanned stations with entry-exit gates having card readers and turnstiles. Functional requirement: control access to restricted areas. Use smart cards with photo ID. Assist in emergency situations for evacuation and head count. Interface with CCTV for monitoring. Access control components requirement: smart cards, contactless, ISO 4443 compliant, readable up to 5 inches, size 82 mm by 52 mm. Smart card readers, located at entry-exit points, must be tamper-proof and weather-resistant. Door gate control units. Turnstile or full-height turnstile gates for personnel, barrier gates for vehicles. Access controller units. Main control units, managing card reader signals and authorizing access. System design requirements. General functionality and system architecture. Centrally managed, Windows-based system with open architecture and the ability to integrate with other critical access control areas. Supports single and multi-user environments with extensive system operator privileges and database management. System capacity. Expandable to 3,000 users and 50 access controllers. Access control system cabinets. Control rooms at main and intermediate control rooms and main terminal. Cabinets for power distribution, Ethernet switch units, and connectivity to SDH system. BVS control rooms. Cabinets for access control units with status monitoring. Workstations. Master and backup access control stations. Standard IBM-compatible PCs with LCD monitors, keyboards, and storage drives. Security access workstation located at main gates with bypassing facilities. Database servers. Contains a database of authorized card information and real-time storage of entry-exit data. Supports redundant configurations with synchronization capabilities and secure access. Communication network. 10100 base T Ethernet network with SDH network interface for long-distance data transmission via fiber optic cables. Access control system management software. Extensive cardholder database with over 50 fields. Real-time activity display, extensive reporting capabilities, and anti-passback functionalities. System revision control for software and database integrity. System time synchronization receives synchronization signals from master station clocks at preset intervals without disrupting operations. These details encapsulate the technical specifications and design requirements for the access control system, generalizing project-specific information. Access control system design, general. The access control systems and transmission equipment are designed to cover various locations spread along the pipeline. The access control gates are required at the main control room, block valve stations, intermediate control room, and main terminal. All block valve stations are unmanned, while the main control room, intermediate control room, and main terminal are manned and have control rooms. Access control is used to permit authorized personnel to enter and exit stations and restricted areas after authentication. Access gates locations. Card readers and gate door controllers are installed at all main gates of control rooms and terminals, including personnel and vehicular gates, control room building main entry and exit doors, substations and switchyard areas, administration buildings. Any other specific restricted areas within the facility as per security operational group requirements. All block valve stations and tie-in stations with access gates for personnel entry, vehicle entry, and control center entry. Access control system locations. Main control room, master access control workstation and printer installed in the administration building. Access control equipment installed in the telecom room of the main control building. Security workstation located at the main security building at the main gate. Intermediate control room. Access control workstation and printer installed in the administration building. Access control equipment installed in the telecom room of the main control building. Security workstation located at the main security building at the main gate. Main terminal. Alternate master access control workstation and printer located in the administration building. Access control equipment installed in the telecom room. Security workstation located at the main security building at the main gate. Block valve stations. All block valve stations are unmanned with a control center having one access control point. Entry-exit gates have 2 card readers, entry and exit, and a full-height turnstile, bidirectional for personnel entries. Similar arrangements are required for vehicle entries. Tie-in stations, unmanned stations with a control center. Entry-exit gates have 2 card readers, entry and exit, and a full-height turnstile, bidirectional for personnel entries. Similar arrangements are required for vehicle entries. Functional requirements. The functional requirements of the access control system include providing access control to facility areas like pumping stations, block valve stations, control rooms, substations, etc. for authorized personnel. Smart cards with photo ID acting as an identity card. Assisting in emergency situations for evacuation and head counting. Interface with CCTV system for detection, recognition, and identification of personnel at entry-exit access gates of unmanned stations. Access control components requirement. Smart cards. Contactless, conforming to ISO 14443 standard, operating at 13.56 MHz, readable up to 5 inches. Robust industry standard ISO credit card size, suitable for printing with a photograph and identity details of the user. Smart card readers. Located at personnel and vehicular entry-exit points, control room entry-exit doors, substations, engineering rooms, administration buildings, and muster points. Wall-mounted, tamper-proof, with visual indicators for system status. Door gate control units. Personnel entry-exit gates fitted with turnstile type or full-height turnstile gates. Vehicular entry-exit gates fitted with smart card readers at suitable heights, interfaced with barrier gates for vertical opening. Building entry-exit doors fitted with swinging glass doors opened manually after lock release. Access controller units. Main control units connected to card readers and door control units. Control and recording of all access control card readers at the main and alternate master control rooms. Operating modes include normal, free, closed, and open modes with anti-passback APB capabilities. General functionality and system architecture. Centrally managed Windows-based system with open architecture. Supports single and multi-user environments. Ability to integrate with photo imaging, alphanumeric paging, and CCTV. Graphical interface including time graphs, full-color icons, and toolbar buttons. Complete facility management, access control, and alarm monitoring. Uniform system upgrades and standardized components across all sites. System capacity, expandable to 3,000 users and 50 access controllers, with each access controller handling 4 to 6 door control units and card readers. Access control system cabinets. Control rooms and block valve stations have cabinets for power distribution, Ethernet switches, and connectivity to the SDH system. Cabinets with lockable doors, cable management panels, and accessories for proper ventilation and equipment protection. Workstations. Master and backup access control stations with standard IBM-compatible PCs, LCD monitors, keyboards, and storage drives. Security access workstations located at main gates with bypassing facilities. Database servers. Contains a database of authorized card information and real-time storage of entry-exit data. Supports redundant configurations with synchronization capabilities and secure access. Communication network. 10100 base T Ethernet network with SDH network interface for long-distance data transmission via fiber optic cables. Access control system management software. Extensive cardholder database with over 50 fields. Real-time activity display, extensive reporting capabilities, and anti-passback functionalities. System revision control for software and database integrity. System time synchronization receives synchronization signals from master station clocks at preset intervals without disrupting operations. These details encapsulate the technical specifications and design requirements for the access control system, generalizing project-specific information. Quality assurance. The access control system vendor must maintain and use a quality system based on ISO 9001, 9002, 9003, 9004 standards to control the work and workmanship. Subcontractors, if used, must also be ISO certified. The vendor must provide a specific quality control plan within 2 weeks of the order award for review and approval. Inspection and testing. All access control system equipment's components must be tested at the manufacturer's facility. The vendor may be required to conduct any or all tests stated in this specification under the purchaser's or its representative's witness. Testing and factory acceptance tests, FAT, of the access control equipment must be performed according to this specification, relevant project documents, and international standards. Factory acceptance tests, FAT, complete functionality test of access control hardware, software, and interfaces. 100% test of all components and functions under witness. Vendor to assemble and carry out integrated factory testing of the access control system, including communication testing, and submit internal test reports prior to witnessing. FAT procedures to be submitted 4 weeks before testing for review and approval. FAT includes visual checks, earthing isolation and continuity measurements, diagnostic features, hardware checks, functionality tests, communications interfaces test, system response tests with all card readers, RFI and EMI testing. Site acceptance test, SAT, starts after installation of access control system across sites with integrated communication systems. Vendor to perform SAT at the job site according to an approved SAT plan. Vendor to provide all personnel, test facilities, equipment, and tools. SAT plan to be prepared by vendor and submitted for approval 2 months before SAT. Testing to demonstrate system compliance performance according to project documents. Vendor responsible for correcting discrepancies noted during SAT free of charge. Total system integration and checkout responsibility on the vendor. Special attention to fiber optic system integrity, continuity, and failure testing. Performance acceptance test, PAT, conducted after successful startup and commissioning of the system. P8 to be carried out under normal operating conditions as per an approved PAT plan and procedure. Vendor to provide technical expertise and support during PAT. P8 test results to be prepared by vendor according to approved PAT plan and submitted to the end user. Documentation. Documentation must enable purchaser and operator to fully understand the product, its operation, application, performance, and maintenance. Drawings to be in accordance with the standard engineering procedures and subject to purchaser's approval. Documents to be submitted include functional specification for the complete system, bill of equipment showing complete reordering information, spare parts location, identification, and price list, installation, operation, and maintenance instructions, equipment general arrangement drawings, heat dissipation load lists, system cabinet general arrangement drawings, system detail termination drawings, system configuration drawings, spare parts and special tools, vendor to include recommended spare parts interchangeable record, SPIR, for startup, commissioning, and 2 years of operation. Spare parts to be packaged to preserve as new condition and properly tagged for identification. Packing lists to be detailed for easy handling without uncrating. Spare parts listing as per industry standards. Training. Training for site personnel on configuration, operation, installation, commissioning, troubleshooting, and maintenance of access control system equipment and systems. Hands-on training conducted either at the end-user site or at the vendor's training center, as per end-user preference.